Okay, it's a fourth degree polynomial. And again, I know it's work. We've done plenty of these problems before, though. You're going to factor it out. And I can write the roots down now. And what I'm going to say over here is looking at it, just, kind of looking at the factored form of it, the roots, and then we'll look at our picture, by the way. The roots are going to be -5, but it occurs twice. It's going to be -2. That occurs once, and a 1. And by the way, I'm expecting to see 4 roots. I see them clear as day. And I want to point out, this is a clear indication of a repeated root over there. It's touching it, but not puncturing there. And then, -2 is right over here. I'm seeing that root, and the 1 over there, I'm seeing that. Now, do I see a y-intercept? Yeah, -50 right over here. They're pretty simple, right? I got a general shape of the curve. Question is, what other information can I get? Well, I can get the first derivative. And I'm going to tell you right now, looking at it, -5 is easy, right? What's this going to be? This is a relative minimum over here. It's not global. But I notice there's a point over here, which is a relative max. And there's a point over here, which is a relative min. By the way, I would not assume that is what it looks like, all right? If you kind of blow that up, I'm going to say it's really over here somewhere. I hope you realize that. By blowing that up, I realize that. Here's the deal, though. The deal about this over here is that if you want to find it, you're going to have to use a quadratic formula. You're going to have to use a quadratic formula. Right? I'm not looking for it, but you have to use it to get those points over there. Now, this guy over here, whoops, I'm sorry. I pointed at the wrong thing. I'm going to go back and say that again. Let me erase. I was pointing at the wrong thing. If you want to find these points over here, you're going to have to solve this for 0. And you'll get them. You get those too. All right? Now, what is the third derivative going to, second derivative going to give us? Points of inflection. You'd have to solve this for points of inflection. Do I see points of inflection? Yes. Concave up. Point of inflection. Concave down. Point of inflection. Concave, whoops, sorry about that. Concave up. I did it again. Concave up. I put the point of inflection over here. POI. POI. If you want those points, what do you have to do? Well, they're not that bad to do. What's it going to be? Plus or minus. What do you get there? 5x squared equals 9. X squared equals 9/5. So it's plus or minus 3 over root 5. And that's what those 2 points are. All right, plus or minus. Did I make a mistake somewhere? Oh, so I did it again. I apologize. I'm looking at the wrong, it didn't make any sense. And I'm glad I looked at that and said it doesn't make any sense. It made no sense at all, because that's not the case. Not even close. If you want to get those points of inflection, you're going to have to solve this. I did that mistake several times already today, which is not bad to do. Let me point out what I mean by that. You have to do 12x squared plus 66x plus 66 equals 0. I'd probably factor a 6 out and divide both sides by 6 maybe. 2x squared plus 11x plus 11 equals 0. And you solve that, and you'll get these 2 points of intersection over. I'm sorry, points of inflection. All right, thank you.